So I wanted to talk about this problem I ran across on the internet because I think it is fantastic. This is a puzzle, and there is no answer for X and Y, so that's not the puzzle. It's more of a broad strokes. So let's see what we recognize here, right? So we have an X squared and we have a Y squared. That is two squares. And between them, we have a minus sign. And whenever you have two squares and a minus sign, you should recognize that this is a pattern. The difference, which means subtracting, the subtracting of squares, the difference of squares, the minusing of squares. Okay, negative squared and a positive squared, one of each sign. I don't know, however you want to look at it, right? Because there would be an imaginary positive sign out here, right? So that was just a joke. This is a difference of squares. That's the technical term for it. And what it is when you'll have two perfect squares subtracted. That is not going to be something you usually start with. It's going to be something you usually try to create. I don't know if you remember FOIL, but FOIL, we would have two things. I hate using X and Y, but that's what this used. We have X and Y times, let's say, W and L, okay? And then there'll be like a plus and a minus, right? So that's a binomial multiplied by another binomial. Two terms. There's two terms. That makes it a binomial. And that's a binomial times another binomial. And then we learned that you're going to FOIL with all that. So when you're FOILing, you multiply first, outside, inside, last on your binomials, right? And that takes off all day. But there are two types of binomials that give you something beautiful. They don't give you four things, right? Because you'd have your first, your outsides, your insides, and your last when you FOIL normally, right? And that's like, you ever do that? It's all day. And you got to do your like terms. But there are two types of binomials you don't have to FOIL. You can just know a pattern. One of those is when you have two things that are exactly the same, but the only thing that's different, that's a Y. Looks like an X. Oh my goodness. My Y's and X's look exactly the same. Let's do it cursive. Okay. So when you have one of each sign, when nothing is different, but the signs are opposite, the O and the I go away. It's so nice. And you're only left with F and L. And that's what this is right here for a special type. It's when you have one of each sign, you're going to end up with only the F and the L. All the rest of it goes away. The F is going to be these two X's multiplied together, which is X squared. And the L lasts these two Y's together. That's it. You're going to only have the two X's and the two Y's. You're not going to have the middle. And by two, I mean squared. You're going to have two copies of X multiplied, two copies of Y multiplied, right? And so when you see one of each sign, but the same two things, that lets you know if you multiply those together, the O and the I go away, and you're only going to be left with this squared and this squared. Oh, look at that mess. That's beautiful. So using all of that here, we can see that this and this makes this when they multiply together. Multiplying one of each sign will make that. So this times this is this. So the question mark is 3. So I thought that was a really cute problem that illustrates difference of squares.